Good morning and good afternoon, everyone. Welcome to our Aviatrix bootcamp today, Getting Next-Gen Firewalls Right in AWS. My name is Frank Cabri, and I'll be hosting the session here this morning. It looks to be a popular topic. We have well over a couple hundred folks registered, and I know some folks are still getting logged in here, but a lot of our customers, a lot of partners. I see a lot of new names maybe that haven't attended one of our boot camps or may not be familiar with Aviatrix. So quickly, our mission is to make cloud networking just as simple as cloud compute and storage are, and to do that, we deliver to customers software-defined cloud routers. That said, we're not really going to talk about the products today. Excuse me. We're going to talk about some of the learnings that we've garnered with a lot of our customers in the area of deploying firewalls, in the area of security best practices, and that's really what the focus of the event is today. And to do that, we have a couple of our regular bootcamp speakers joining us. I want to welcome and introduce first Sherry Way. Sherry's our founder and CTO. Sherry, welcome.
Thank you.
And then we have Neil Kamal. Neil heads up all of our field operations, including our solution architects as well. Neil, thanks for being here.
Thanks.
And between the two, Neil and Sherry have worked with hundreds of customers doing these types of designs and deployments. I mean, these could be customers born in the cloud, have a half dozen VPCs, to larger financials, media companies, insurance companies that have hundreds of VPCs. So today we're going to get into the topic of firewalls in AWS. We're going to talk about what some of the native options are that AWS provides and how you may want to augment those capabilities. But the meat of it is really going to get into some of the design patterns based on the use cases that you want to achieve for inline security. And that'll be the bulk of it. And then we'll talk about the advantages and disadvantages of each of those different design patterns. And then we're going to actually add a demo. So we're going to show some integration with next-gen firewalls, which will be a good look at that, how that works in the real world. And then at this time, anytime you can enter questions into that chat window. Just push that button that you see on the slide there at any time. We'll either take the question in line and answer it as we go through the deck, or save 15 minutes at the end to do that. So with that, let's go ahead and I'll turn it over to Neil and Sherry, and we'll get started.
Thanks, Frank, and good morning, good afternoon, everyone. So let's get started. I think you have seen this slide many times in reInvent, in AWS events, and on the website. Security in AWS is a shared responsibility. What happens in the journey of migrating to the cloud or adopting AWS or Azure or other cloud providers is initially people are kicking the tires. There is backup as a use case or one of the internal application, and that's how it gets started. In fact, for many companies, it starts in silos. A team somewhere will start with a QA or testing, but very quickly people start realizing the value of the cloud and how, and then it takes the center stage and it becomes mission critical. As that happens, two things happen. One, your spend goes up into the AWS, and security becomes a growing, budding concern. And as that happens, people start looking, your security team start looking into it, and they start recommending security best practices. You as customers start asking, what are some of those things? One such topic is firewall. How do we firewall the cloud? What is the role of the firewall in the cloud? What can I achieve with it? What are the ways? What are the challenges? All of that. And that's what we're going to spend the next 40 minutes discussing. So let's get into it. Sherry, maybe you can start with what is available natively in the arena of security and firewalling.
Sure. The AWS offers actually a variety of security services, starting from NAT gateway as a service. I think that instance was NAT, which internet-bound traffic to go through the NAT gateway service. AWS introduced Guard Duty, which is a comprehensive IDS type of detection, and then the Inspector and Macy AWS Shield is for inbound DDoS attack for inline. So
these are the native services. So what's missing?
Yes. So what's missing is in a lot of times the enterprise, when we talk to customers, they say they need the inline security services. And the inline security services, a lot of it comes from compliance requirements, comes from the traditional IDS, IPS filtering that they have been doing on-prem. And so from customer point of view, it's a natural next step, an extension to bring the firewall to the cloud. And because the requirement has not changed, even though the playground has changed from on-prem to cloud. So
you mean to say when it was data center, they already had inline security services in the name of firewall.
That's correct.
And
yes.
now that the cloud is becoming a significant part of the strategy for the company, they need the same inline security services in the cloud.
Yes, both for compliance, best practice, and what the regulatory and their auditing require them to do.
Okay, that makes sense. So then we move to how do you bring inline services or firewall into the cloud? So let's look into it. There are a variety of design patterns, as you would imagine, because this is not a new problem. I mean, cloud is what, 10, 12 years old? Migrating your firewall into the cloud has been around, if not all 10, 12 years, at least for the last 6 years. And in those time period, the cloud providers themselves have evolved and the security providers have evolved too. And through those evolutions, different design patterns are prevalent. And these design patterns have their advantages, their disadvantages, and the core requirement or the need or the use case that they are good for. So we're going to look at a bunch of those. And there are a lot of these that we are going to share, some in details, other at high level. And feel free to ask specific questions related to your design pattern that you might be on, and we will try to answer them. So the first one, distributed egress control. If you have application in the cloud, certainly they need access to internet or other sites outside of the cloud. How do you do egress control and how do you do it in a distributed way? That's first pattern. Second is proxy-based. Generally, SQUID is one of the popular proxy. So proxy-based egress control. Number 3, centralized egress control. Number 4, centralized east-west firewalling. East-west generally refers to from cloud to another cloud, VPCs to another VPCs, VNet to another VNet. So east-west is about horizontal in the cloud. Number 5, centralized north-south firewalling. North-south refers to cloud in the north, data center in the south. No reason why one is on the top of the other. It's not because we prefer cloud more than the data center. It's just, you can say north-south or south-north, whichever we choose. Centralized north-south firewalling. And lastly, and finally, this is the latest entry, probably 6 months old, coincides with Amazon TTW release, but this is about transit DMZ architecture, an ability to create a DMZ, demilitarized zone, into the cloud itself. These are the 6, at least in our experience of working with customer in the last 5 years, these are the 6 very common prevalent use cases.
Yeah, it covers all the traffic flows, east-west, going to internet, and from on-prem to cloud.
Correct.
Yeah.
And as Neil moves to the next slide, I'll just answer this one question about will slides be provided. Yes, of course, we will follow up with you. You'll automatically get these slides. I just wanted to let you know now so you don't have to feel you take all the notes as we go through it. We'll get you the slides. Go ahead, Neil. Sorry.
Okay, so let's deep dive into all of them. The first one, distributed egress control. What is the use case? The use case where it is needed is AWS NAT Gateway plus FQDN fully qualified domain name policy. So for those customers who are either already using or plan to use the NAT Gateway for IGW and internet access, but they need a fully qualified domain name, a better way to manage policy at a URL level, that's the use case. And as you can see from the picture, VPC is going to internet, and you have your green list and the red list in the URLs that you are allowing and denying. And
in this egress deployment, you have a firewall or the appliance into each VPC. So
correct.
It's distributed.
It's distributed. That's the idea. Distributed meaning every VPC has this control. The second use case why this is needed, and this you would find numerous reference in PCI, even HIPAA, is compliance of the internet bound traffic. where the compliance directly says that you have to have a control over where the packets are going on internet from your applications, if those applications are PCI or HIPAA type, and so on and so forth. So those are the two high-level requirements that drive this use case. There are many more that might be driving you to control your egress. Now, what is the advantage of this design pattern? And the key word here is distributed. So what is the advantage of distributedness of this design pattern? First, it's the best performing design because it has extremely low latency. The packets go from the machine directly out to internet. There is no more hopping around. It's all direct, and therefore this is extremely low latency. And secondly, low data egress charge. As you know, some of you painfully, that in AWS, there is a cost of data egress. When the packet goes from a VPC to another VPC, there is a cost to it. Packet goes from VPC to on-prem, there is a cost to it. Packet goes from VPC out to internet, there is cost to it. And this cost accumulates and comes as a line item in your bill. If you are sending the data or doing the egress control in a distributed fashion, then the egress charges are minimal or the lowest possible. What are the disadvantages? Sherry, maybe you can talk about that.
Yeah, so because you deploy such function in each VPC, if you don't have a central control, then to manage in these large number of devices or appliances is very challenging and difficult to operationally.
Right. Yeah, so you need a central console, otherwise this is pretty difficult. And finally, it is expensive, or it can be expensive, because if you put a firewall which runs in a very large instance size, because firewalls were designed to run on a specific hardware from an on-prem, and if you take the same firewall, put it in the cloud, runs on a very large instance, you will be burning a lot of cash because as it grows in number of VPCs. So these are the disadvantages.
Yeah, I think because this use case specific says FQDN, egress control, the firewalls are capable of doing a lot more. So for this kind of use case, deploying in a distributed fashion, not only is hard to manage, but it also can be very expensive.
Right.
Yeah.
And it is therefore, it is an overkill. People don't really put a firewall in every single VPC. However, the design pattern that is extremely popular, almost to the extent viral, is the following. And we have a moment of power.
Another housekeeping question came in, just the idea of, is the webinar going to be available? Yeah, so in line with the earlier question, you'll get all the slides, and then you'll also get a link to the recorded webinar that should be by end of day Friday, perhaps Monday at the latest.
Thanks, Frank. Okay. So people don't really put firewall. However, the technology which is extremely popular for this use case, well advertised also on AWS, is Aviatrix egress filter. What that does, the advantage is, it still has you the best, or gives you the best performance because the gateway is in every single VPC and gives you the low latency. It preserves your low data egress charges because you're not sending packets somewhere else, and it gives you the central console. You can see in the picture Aviatrix controller and distributed execution, the best of the both worlds. So using this technology, you are able to have the first design pattern, which is distributed egress control. Let's go to the next one. The next one is SQUID-based egress control or proxy-based egress control. So the use case is, again, the same requirement that I have AWS NAT gateway and I want fully qualified domain name policies. How do I do that? And compliance for internet-bound traffic. The advantage of a proxy-based system is that you can add policies to egress, right? That it solves the problem for you. However, it has many disadvantages. The first disadvantage, it cannot do filtration of non-HTTP or HTTPS traffic. So while you feel like you're protected, you're not really, because it's very easy to steal data by doing SFTP or SSH back to somewhere else, some other site that is going to be problematic. The second disadvantage of the proxy deployment is it requires an agent. And that's pretty problematic because this agent then needs to be in every single instance or VPC.
Yeah, so there are actually two types of deployment for SQUID. There is a transparent, there is a proxy-based. So this, if you deploy proxy-based, obviously you have to deploy an agent in every instance, and you have to configure proxy. So it's a friction. But proxy does, SQUID does offer a transparent proxy where it's agentless.
Okay.
Yeah, but it.
And then the next problem is no multi-AZ or HA support, which, if you have just a few VPCs, your non-mission critical application, you might be okay with. But as soon as you have things that are mission critical, sensitive, you would not want to run it in without multiple AZ, HA support. Right. Okay. And then finally, centralized proxy add extra hop. This is going to be a departure from a distributed design. So in any centralized design, including this one, now you have one more hop, and that costs additional data egress charges. So that's our number 2. Let's look at third one. This one used to be actually very popular design for a long period of time. This is about centralized egress using a firewall. So what are the use cases? The use cases is the same, that I want to control VPC egress traffic. But there are a few more things than before. I want to do IDS and IPS for egress, and some other, data inspection services, inline services. What is the advantage of this design? Because it has been very popular, it must be advantageous. So the one good part of this is that you can manage everything from one application, from one firewall instance. And therefore, you don't need an army of firewalls or army of security engineers managing it. So that's a good part. The second good part is, and that became almost a pattern, is bring your own firewall. Most of these organizations which are moving to the cloud have a favorite firewall that they have been running on-prem. So it allows you to take the same firewall, a virtualized version of it, move it to the cloud, and achieve centralized egress control using that firewall. So those are the two advantages of this design. Sherry, maybe you can speak to the disadvantages of this design.
Obviously, in this design, you need to run a IPsec tunnel to each VPC in order to bring traffic to the centralized place. So we know that IPsec today is in AWS with VGW is capped around 1 gigabit per second. So that is your total throughput out of a VPC. In addition, when firewall is really designed to run firewall services. They're not good at building IPsec tunnels. With that many IPsec tunnels bring to firewall, it will significantly degrade the firewall performance because of these IPsec tunnels.
That's very interesting. So on that point, when you say IPsec performance is capped at 1 gig, if it was distributed, what was the throughput that you could get versus if it is 1 gig? Or in comparison to what?
Yeah, I think the data we have heard, firewall by itself can achieve up to 4 gigabit, but when you run IPsec, we heard it's around hundreds of megabit per second.
Wow.
So it's significantly lower.
10x. Yeah. And then in terms of routing itself, if it is bringing the packet to the firewall, it goes out to 1 gig. If it goes direct, is it 5 gig? Is it 10 gig? What is the maximum you can get if you are not building IPsec?
Yeah, it's 4 gig, right?
4 gig, yeah. Okay, great. So those are the two disadvantages, both around bottlenecking of the performance. And finally, the last one, this used to be the problem. First, the problem was you have to build IPsec tunnels. And building IPsec tunnels, for those of you who have done it, is problematic. Now, if you have 100 VPC, you're building 100 IPsec tunnels. Very problematic. Then came a little bit of an improvement where there is a Lambda script to try and automate it. But then you have to deal with somebody else's script. It is not really supported. You can't modify it because, again, it is somebody else's script. And so it remains, the whole setup is a problem in this space. Setup takes time, effort, and then all of these tunnels are then BGP, which means operation is also extremely complex. So while this has been a popular design for many years, it has lived its time and people are migrating away from this design.
Neil, can I take a question just
sure.
just quickly? Why is a VPN needed here from each VPC to the firewall?
Great question.
Yeah. So before there was AWS Transit Gateway, before the TGW time, the AWS did not have a transit solution. The only way to move traffic from VPC to another to egress is through tunnels, which the only tunnel exists is IPsec tunnels. So that's why this is the way to move traffic transitively from, let's say, VPC 1 to this particular egress VPC to internet. It's considered transitive. Of course, this is not VPC 1 to VPC egress. The traffic is to internet. So from AWS point of view, this is considered transitive. And the only way to do transitive is through IPsec tunneling.
Correct.
So that's why.
That's
great. Thank you.
Okay, so this was a popular design, but because of the setup and performance limitation, people are moving out of it.
Yeah, and in fact, the previous SQUID architecture, if it's centralized, you have to run IPsec tunnel also.
As well. Yeah. So number 2 was problematic. Number 3A is problematic. However, the modern design, which is 3B, using TGW, makes it better. So let's look at the 3B, which is centralized egress using TGW. So the use case is the same, right? You're trying to control the VPC traffic, IDS, IPS. Advantages, best firewall performance, because now you are not building IPsec tunnels. Instead, you are using AWS native Transit Gateway to connect all of this. And so you can get to up to 50 gig performance, much improved. Disadvantage, you still are running Lambda scripts and things like that, or an external script to manage HA configuration. This is a big one, and this is problematic.
So one of the problems with this is that TGW, in this case, the security service VPCs shows up as a spoke to the TGW, and AWS TGW insert or present itself as an elastic network instance to the security service, and TGW is not session aware, so it cannot do load balancing natively, so you can only get one firewall in there. And in addition, if that firewall died, the TGW or anybody else has no knowledge of that, so you cannot spin up a second firewall. So that's why it says it requires external Lambda script to monitor and to manage the multi-AZ deployment. And AWS does offer. Are we going there, or do we go to the next one?
Yeah, we go to the next one. Okay. So to summarize, 3B is better than 3A, where it was all IPsec, because it does alleviate the performance bottleneck. So you are able to get much better performance. However, it still is problematic from setup and HA and those perspectives. So it will have its challenges. Let's go to 4A. This is not about egress. Now we are going and taking a direction into the next set of firewalling requirement, which is East-West Firewalling. So what is the requirement? The requirement is network segmentation. That dev should not be talking to prod, and the database should only be talking to the app server, but the app cannot talk to things like that. These are things that the firewall has traditionally been helping. What is the advantage of this design? The natural one appliance to manage everything, right? You only have one appliance, so that's good. That's centralized. Second advantage, you can bring your own firewall. You might already have a favorite. Just bring your favorite firewall, no problem there. However, a bunch of disadvantages. First disadvantage is the same problem as before, IPsec. IPsec is a problem, guys. 1 gig is not enough, and that too setup is pretty damn complicated. Then firewalls don't play very good with IPsec. So you're not only reducing your network performance, you're bringing down your firewall performance. What does that mean? You might need 5 of those firewalls rather than 1 firewall. So it's problematic for performance, and then if you throw in money, then you can solve it to some extent, but then you'll have other problems. And finally, you still will you have to deal with that Lambda function from an operation and setup perspective, something that people hated to begin with. So this is not something that we see a whole lot. I mean, there are people who didn't have an alternative before who adopted this 3 years ago, but all of them are looking for a way to migrate to a better design. Let's look at the new one. The 4B is trying to do the same using AWS Transit Gateway. This has many advantages. So use cases, same use case. Advantage, it's an AWS native service, which is Transit Gateway. Amazing performance and zero additional performance impact. So it is going to give you 50 gig of raw network throughput, and it's a service, so it's probably going to live forever, and it's not going to give you any problems. Disadvantage. Let's look at disadvantage of this design. First is you have to have external script to manage HA. Managing HA is not simple in this area, again, because of this, there is no session stickiness. So you will have to figure a way out, and that's problematic. The second is, if you try to do a multi-AZ setup so that you are building resiliency in this, you would have to SNAT your packet. Now, it's not that SNATing is difficult, meaning that is a challenge too. But the bigger part is as soon as you source NAT it, now you have lost the sources. It will look like all your packets are coming from the firewall. So what's the advantage? You can't really filter saying that the packet's coming from X to Y filter, because X is lost now. It's all going to look like it's coming from the firewall. So this is not really a solution. We have seen painfully a lot of customers trying to do that because they have to figure it out. And after TGW was released in December, there was a lot of migration to it. But for a brief period of time, there was no better alternative. As we go further, you will see that there is a design that really helps the situation. So
yeah, I just want to add why this require SNAT is a problem. From what our understanding with customers is that a lot of the applications, they want to see the original source traffic, so that they can either run statistics, or they can have better logging capability, logging visibilities and things like that.
Yeah.
If you SNAT it to the firewall's IP address, you lose all of that. It looks like all the traffic go to firewall. All the traffic doesn't come from firewall.
Correct.
So that's, yeah.
And we are saving the solution for the last. But the solution is not that we go take you back to IPsec, because you hated that to begin with. So here is the evolution that you should read. The first generation of design, all IPsec, pretty problematic. Second generation of design, use TGW, but problematic from HA and multi-AZ and all of that. And the third gen, you wait another 5 minutes and you will see what it is. And that's pretty exciting, pretty powerful. So, and the last part of the disadvantage of this, manual updates to routing table. This is a big one. See, I mean, when it was the previous era, it was IPsec. So while you hated the performance and you hated the setup, the advantage was it was BGP. So all routes were being taken care of. You didn't have to operate it in a static mode. It was all dynamic routing. So now that we move to this design, which is 4B, no more performance problem, no more IPsec issues. However, now it is all static. You are responsible for updating routes.
Right. So for example, when you add a new VPC, you have to go to firewall, add routes to go out. So every time you have to do that. So it all requires manual configuration or updates.
Correct. So
whereas before, the BGP will carry it, and so your firewall will be automatically updated whenever you introduce a new VPC, and the routes would be programmed on the firewall.
Correct.
Not to mention the VPC route tables and TGW route tables. Today, none of them.
None of them, yeah. Your firewall will need update. You might have to update your TGW. You might have to update your VPC's route table. So let's keep on going. The next pattern is about North-South firewalling. So far we talked about egress, we talked about East-West, now we're talking about North-South. North-South has the same type of situation. The use case is firewalling on-prem to the cloud traffic. The advantages, same thing, one appliance to manage, bring your own firewall. Disadvantages, same thing, IPsec tunnel, people hated it. firewall performance goes down and require an external script to manage. So same thing. 5B made it better with TGW, where now you don't have the limitation of the performance, but multi-AZ is a problem, doesn't work with ECMP, manual updates to the routing table is the problem, it's all static, so still problematic. And therefore, we bring you the final design, which is the Transit DMZ architecture, and that using Aviatrix. There are multiple parts of this, but in net, this is an architecture that solves your egress, it solves your north-south, it solves your east-west, and it solves your configuration and HA problems, it solves your multi-AZ level problems, and it uses the newly announced AWS TGW, and therefore it solves your performance and throughput problems too. This is the design where we have also taken care of updating routes automatically. So it is really the best of all worlds in some ways, and let's look at it further. So firewall north-south egress and ingress traffic, egress and ingress advantages. Use the new AWS Transit Gateway, the best firewall performance because you're not doing IPsec. Allow firewalls to scale horizontally. You can add more firewalls in this VPC. Disadvantages, not really. Sherry, what am I missing? What else can we add to this?
So the idea of this, as you know, we kind of went through this presentation, it became obvious that firewalls do not want to do a lot of network functions, because when they do network functions, it degrades the firewall performance. So what we've really thought through about this design is use Aviatrix architecture to allow firewall to be the best at what they do, and allow firewall to be slide in this we call edge transit VPC, and so firewall can scale while Aviatrix takes care of the routing. What we haven't got into a lot of discussion is really the when you dynamic add a spoke, how the routes get automatically propagated to on-prem and on-prem to the spoke VPCs while going through the firewall service. And the relationship between the gateways and the firewalls are through AWS native routing, through their subnets and native routing infrastructure. So there is no performance impact on the firewall. And the rest. So the entire architecture allows you to not only solve your network problem of building a transit network, but also solve the firewall security problem that when you put two architectures together, a lot of times they conflict, and so this solves for that.
Great. So that's the presentation. We talked about all of the use cases. Now we are going to go into a demo where we're going to show you your Amazon VPCs using TGW with a firewall. We have TAN, Palo Alto Networks, as firewall in this example. And we are going to show you how using Aviatrix transit design or a transit DMZ architecture, you will be able to achieve all of it.
Yeah. So in this demo, maybe I can first describe quickly. This is I have two regions, US East 1 and US West 2. Each, TGW is a regional construct, so each one has its own TGW and has spoke attached to it. And then we have a transit VPC where we deploy PAN into Palo Alto VM series into this transit DMZ. The Aviatrix transit DMZ has done a lot of integration. The problems we talked about where, the PANs, who's going to update the PANs route tables, the Aviatrix controller takes care of that. Mm-hmm. So what I'm going to demo to you first is I have an instance in US East 1. I'm able to ping across the region. We also have cross region to this transit VPC, which is in Oregon, and then ping a instance on-prem. So to show you that go through PAN and ping on-prem. And then I will show you, if we have time, I would detach this spoke, and you will see that the route the route of this VPC seeder gets deleted on the PAN, therefore the connectivity is lost. So these are the two steps.
One question that came in, Sherry, the connection between the two Aviatrix gateway, which is sandwiching the firewall, is that IPsec?
No, it is native. Folks, if you guys want to learn more, you can go to docs.avx.com and look at the DMZ. You can send it on the chat. Yeah. Okay. So let's go take a look at the demo. So over here, I have, in my Oregon, in Virginia, I have this host, and I'm going to pin this to on-prem. My on-prem is 10.14.1.86. And if I go to pin from Virginia host, you can see that the ping goes through. And here I have a PAN inserted in there. And if you look at the PAN's virtual router, the Virginia VPC spoke has 10.9.0.0/20, and the routes is already added. Therefore, I can pin. And these routes coming from the west side Oregon and east side Virginia, and also on-prem. So they all presented to PAN on two interfaces. If you look
you are just explaining the setup.
That's right. Yes, okay. Yes. If you look at the zones, I have a zone cloud and zone on-prem.
Okay.
So Aviatrix has an orchestrator that allows you to build a network architecture transit that you can abstract it all the layers and perform a lot of functions BGP does, so that you do not have to do manual updates. So right now, what I'm going to demonstrate to you is if I detach this Virginia Spoke 1, and you can watch the impact of how through API, Aviatrix controller can manage Palo Alto VM series of automatically updating the route tables. And taking care of make sure the system works.
So let's go through it one way. We have not shown you, but in this setup, we have multiple VPCs connected via a TGW connected to Aviatrix gateway, which is then the two Aviatrix gateway, and the Palo Alto is a sandwich in between, or is sitting in between. Now, to build this setup itself, also there is an orchestration layer, and if you follow the steps of TGW orchestrator, it builds the whole thing. It has 7 steps that you can follow, which will allow you, it makes it brain dead. It makes it extremely simple for you to follow those 7 steps and build this into architecture. Once you have built this architecture, what Sherry is showing you, that if you disconnect a particular VPC, you don't have to go update the route table, you don't have to go update the tunnels or connectivity, you don't have to go and update the firewall. Everything is taken care of for you as you add a VPC or remove a VPC.
Okay, so now let's go back to so it's still, this takes a couple of minutes because the controller is running APIs on behalf of the accounts, the AWS accounts, and to actually detach the spoke from the transit gateway. And the API, the AWS API itself, is the one that's taking most of the time here.
So Neil, a question came in, something you just said, is the TGW orchestrator part of the AWS TGW or part of Aviatrix's offering?
Great question. So it's part of Aviatrix offering. For some of you are Aviatrix customer on the call, so you already know that Aviatrix is available on AWS Marketplace. You can just go there, launch Aviatrix metered AMI from Marketplace, and by doing that, you will have an Aviatrix controller. Once you have the controller, during the setup time, you give AMI or the access to IAM role access to your AWS accounts. After you give that access, you can just simply follow the workflow, and it will build the transit for you. It will build the TGW DMZ for you. It will attach your firewall to you. It will do the whole thing.
Great.
Yeah. So in this case, detach finished. So if I come back to PAN, instance and look at my routes and make sure I refresh it, as you can see that 10.9.0.0/20 is gone. So this is how
the integration is
integration with the API. We not only do route updates, we also monitor the PAN health so that we do the HA switchover, and you do not need external scripts. It's all integrated into part of the product. So we do the networking part so that the firewall can play its part with its best possible scenario.
Great. I have pasted the link to the docs on the website. The part about this solution is it's orchestrating everything. It's orchestrating AWS, it's orchestrating your firewall, it is orchestrating the build part of the tunnel, it is orchestrating the route updates part of it. The whole thing is orchestrated. In this demo, it is hard to show you all of those orchestration because we'll run out of time. But the link that we have pasted there, as well as in the follow-up email, you will see a detailed illustration of all of those orchestration.
Great. And there's a couple other questions, but while we take those, again, just encourage you to, if you do have questions, just add them in the chat window there, and we'll take them in the order that they come in. One was, I'm not sure when this one came in. It was a little around probably the DMZ architecture, but how do you limit the route propagation? I think it's more around how does the DMZ architecture that we talked about limit route propagation?
Limit or enable?
Yeah, let's talk about both. Yeah.
So enable is about, so if you look at that picture of the, should we go there? Yeah. So what happened is Aviatrix, there is a BGP session running from the Aviatrix gateway that taking up the routes from the on-prem, and the controller knows all the spokes. So the controller essentially is doing the job of BGP propagation, of propagating routes to the spoke VPCs and also propagating routes to the firewalls. And so that's how we enable that. There's really no limitation. If you are thinking about in your mind the VGW 100 route limits, which is well established in the industry, we have a deployment where we can overcome that.
Great. I see Neil's answering some of the questions in line here, so everybody can get visibility on that. One question was, you talked about Transit Gateway a fair amount. How does the Aviatrix product orchestrator complement that? Do I need both? How does it complement the native Transit Gateway service? Right.
So we actually leverage the native Transit Gateway. Our philosophy is whenever we can, we use native service. So you have the best in terms of the performance and in terms of the capabilities. However, we complement. So the Aviatrix orchestrator builds on TGW and made it into a workflow-based. If you guys have looked into how the Transit Gateway limitations, the Transit Gateway, while it simplifies VPC to VPC connectivity, it does not propagate routes from on-prem to the spokes. So the routes are propagated to TGW Transit Gateway, but they're not propagated to the route. So it's left to you. It's like you used to have a VPC function. Right now you do not. So that function is filled by Aviatrix controller.
Great. And let me go ahead and just ask to advance to the next slide as we take a couple more questions. Is it possible to use Terraform with the controller to provision TGW and the attachments?
That's absolutely true. Yes. Yeah.
And more so, like we get this question a lot. For our customers, those who are using Aviatrix, they're absolutely delighted by how Aviatrix helps you with Terraform. For anything that has REST API, you can use Terraform. But what Aviatrix does, it gives you the right calls to make. You won't be calling 15 different calls. To build this is down to 3 or 4 calls, which makes your Terraform script extremely simple, and all the complexity then lives inside the Aviatrix product. But very good question.
Great. Given what you talked about with another question, given what you talked about with the design for Transit DMZ, is there an easy path to migrate to this architecture from the one we're currently using?
It's a very good question. So what we have seen in last 3 months, that there are people who, after the announcement of AWS TGW, it's almost like a frenzy of people who wants to ditch their old design and want to adopt AWS TGW, and rightly so. It is simpler, it is better, it's more powerful, it is cheaper, it has all the right things, and it is cloud native. So migrating out of that design is complicated. Your previous design had IPsec tunnels, and obviously now you do not want downtime. So we have written a proper migration path for each one of these 5 design patterns down to 6th one. So please reach out to Aviatrix team at info@aviatrix.com and ask for migration steps through cloud experts, and we will share the migration steps which require, I won't say 0 downtime, but a minimal amount of downtime. It's optimized for reducing downtime.
Great. Yeah, and so if you want to get your hands on this functionality, there's a variety of ways to do that. You can go to aviatrix.com and click on the orange button in the upper right that we showed there in the picture, and that'll take you to the Marketplace AMI that Neil talked about earlier. You can get started that way. If you want us to work with you on that, just send an email to info@aviatrix.com. Again, you'll get all the information that we talked about, the slides and the recorded webinar as a follow-up to this. We do show in the picture, if you want instant questions and you want them answered now, you can go to our website and just engage in a live chat, and one of our solution architects will be on hand to answer any questions. That's another way you can get started. But with that, I think we've answered all the questions. Sherry and Neil, thanks for both the information and the great demo, and we appreciate you all joining us, and we look forward to seeing you next month on the next topic for boot camps. Thanks a lot, and have a great day.